All right, geometry, it's your lucky day, right? This is one of those very few times where you get the bonus third video. Yes, I know you're so excited. So here we go. More problem focused, okay, using these trapezoids. So example 4, it says all horizontal beams of the high voltage transmission tower are parallel. All horizontals, okay? The top section isosceles trapezoid, the center section isosceles trapezoid. If the measure of angle 1 is 138, what is the measure of angle 2? So the top section is an isosceles trapezoid, right? So we know that this top and bottom base are parallel. Now this angle here is 138. Now the one thing we didn't talk about, I'm going to draw this trapezoid separate right here, right? Is that because the top and bottom are parallel, and this is 138, right? Well, first of all, it's isosceles, yes? So we know that this angle and this angle are congruent on the top base, and these two angles are congruent on the bottom base. So if this is 2, that is 2. If this is 138, then this is 138. Because these lines are parallel, we can treat this as parallel lines. I'm going to extend it. And the legs as transversals. And if you notice that these two angles, they are same side interior angles. And based off of our parallel lines discussion, same side interior angles are supplementary. And that's the idea here, right? The measure of angle 2 plus 138 should equal 180. So we just subtract 138 from 180, and the measure of angle 2 is 42 degrees. And there we go. No problem. Now, that is not just in an isosceles trapezoid, that's in any trapezoid, right? But if it was a different trapezoid, they would have to give you the two angles, or the angles would have to be on the same leg, right? In this problem, if this was not isosceles, you could not do it. Because if they give you angle 1 here, if they give you angle 1 here, the only other angle you could find would be right there using the same side interior angles. I think it's a postulate. Okay. Here we go. Oh, sorry. Okay. B. It says now one cross support of the center of the tower measures 4c plus 3, and the other measures 6c minus 5. What is the length of each cross support? So this is isosceles again. 14 and 14 congruent legs. So your diagonals are congruent. The diags are congruent. So we simply take 4c plus 3, one diagonal, and set it equal to 6c minus 5. No like terms on one side or the other side, so we're going to combine across the equal sign. Let's subtract 4c. 3 equals 2c minus 5. Now we get c by itself. Add the constant, the 5. 3 plus 5 is 8. And now that 2 is multiplying, so divide by 2. And we get a c value of 4. So if your c value is 4, pick one of the supports and plug it in. I picked this one. 4 times c, which is 4, plus 3. 4 times 4 is 16, plus 3 is 19. And that would be the length of each support, 19. And it is in feet because of the 14 feet. Okay, now one more idea here is what's called the trapezoid midsegment theorem. There's also a triangle midsegment theorem. I think we'll do it in topic 7, I think. But it says in a trapezoid, the segment containing the midpoints of the two legs is parallel to the bases, and its length is half the sum of the lengths of the bases. So notice that this is just for any old trapezoid, in a trapezoid, not an isosceles trapezoid, in a trapezoid, okay? But this is called the trapezoid midsegment theorem. So in this picture here, because of these congruent markings, x and y are midpoints. So segment xy is called a midsegment. Again, it's a segment joining two midpoints, midsegment. What it says here is that it's also going to be parallel to those bases, and its length is half the sum of the two bases. So over here in this picture, right, notice that x and y are midpoints. So notice that segment xy is parallel to segment BC and AD, right? They're all parallel. And 7.1 is going to be half of 4.2 plus 10, half the sum of the other bases. 4 plus 2 plus 10 is 14.2. Half of 14.2, half of 14 is 7, half of 2 is 1. That checks out. Now let's go explore more using the tool here. So again, I can drag this however I want to, right? They stay parallel. Again, doesn't matter what the trapezoid looks like. Here I can try to change the length. So let's try to make some nice numbers if I can. No, so I'm not going to waste my time. But there you go, right? You can see that they're parallel still. And if you were to take 7.8 and compare it to half of 3.8 plus 11.8, you get it to work out. Okay. All right, so let's do one problem involving a trapezoid midsegment. All right, so it says Paxton makes trapezoidal handbags for her friends. She stitches decorative trim along the top, middle, and bottom of both sides of the handbags. How much trim does she need for the 3 handbags? Explain. So again, these are trapezoids. She puts a decorative trim along the top, the middle, and the bottom on both sides. Okay? So she's going to put trim along the top, the middle, and the bottom. So right now we know that the top is 6 and the bottom is 9. We need to find the length of the middle section. Well, over here, 2 inches and 2 inches. These are congruent. 2 inches, 2 inches. These are congruent. These 2 points are midpoints. This is a midsegment. So this is a midsegment. To find the length of x, we need to take half the sum of 6 and 9. That's 15. Half of 15 is 7.5. So this length is 7.5 inches. So to find how much she needs for one side, we're going to add 6 plus 7.5 plus 9. That's 15 plus 7.5 is 22.5 inches. Now for both sides, we need to double that. And that would become 45. So for both sides of one handbag, she needs 45 inches. But now we need 3 handbags. So to do 3 handbags, we do 3 times 45. And 3 times 45 is 135 inches. That's how much trim she would need to trim 3 handbags, trapezoids, with the top, middle, and bottom on both sides. Okay. All right, thanks for watching these 3 videos, and we'll see you in class.